Okay, so what an ice table means is that you're going to take your initial, it's an acronym, initial conditions. The C means change, as in what has changed from my initial conditions to my equilibrium conditions. And then E means at equilibrium. So we have an example here, and the example tells us that our initial concentrations for the reaction between hydrogen gas and iodine gas yields HI, 2 moles of HI. When you're doing ice tables, you must be very careful that you pay attention to your molar ratios. You must be very, very concentrate on that very much, all right? So your ice table, initial change equilibrium. Whatever my initial concentrations are. So in our example, it told us our initial concentration of H2 is 1 times 10 to the negative third molar. My I2 was 2 times 10 to the negative third molar. What about my HI? So here I have my reactants, and here's my product. I means initial, initially, when I'm going to mix them together. So initially, I have 1 times 10 to the negative 3 molar of hydrogen and 2 times 10 to the negative 3 molar of iodine. What's my concentration of my product initially? 0. I haven't formed any yet. 0. So these are my initial conditions. The problem goes on to tell you that this system is then mixed. All the juggling and fighting goes on up front. It reaches equilibrium. When it reaches equilibrium, what is my product's concentration? Once it reaches equilibrium, 1.87 times 10 to the negative 3 molar. Now I've reached equilibrium. The change that happened here, as these disappeared, these appeared. Remember, as your reactants disappear, your products appear. So I went from 0 to 1.87 times 10 to the negative third. That means my change was I added 1.87 times 10 to the negative third. Because that's all we're doing here in an ice table. We're subtracting on the reactants and we're adding on the products. Disappearance, appearance. So I went from 0 to 1.87. That means I added 1.87. What did I subtract from these? This is the tough part. If this were a 1-to-1 ratio, a 1-to-1 molar ratio, whatever I added here would be subtracted here if this were 1-to-1. But it's not. This is a 1-to-2 and 1-to-2 ratio. So for that, whatever 1.87 times 10 to the negative third divided by 2 is. Does anybody have that? What is that? Louder. 9.35 times 10 to the negative 4. Finish this and then I'll take questions. So 1 minus 9.35 times 10 to the negative 4 equals what? As soon as we get the answer, we'll talk about it. To the 1. Times 10 to the negative 5. Right. So to summarize, initial concentrations of reactants, 0 concentration on product. We reach equilibrium, we're told we have this concentration at equilibrium, which means the change that occurred between initial and equilibrium was an addition, an appearance of 1.87. That is equal to the disappearance on this side. And the only reason we divided it by 2 is because we have a molar ratio of 1 to 2. If this were a molar ratio of 1 to 1, the number would be the same. This would be minus 1.87 minus 1.87. We actually go through and do the math. This minus this equals this. This minus this equals this. And now we have our equilibrium concentrations. So that we can plug it into HI is 1.87 times 10 to the minus 3 raised to the 2 divided by, we're solving for Kc, our concentrations here. So our hydrogen concentration is 6.5 times 10 to the negative 5 times 1.065 times 10 to the negative 4.